This is Seth Allen. I'm the Sales and Marketing Manager here at Tycon. Appreciate you joining the webinar. I look forward to doing some instruction and explaining our products as we and see how we do our different designs for our RemotePro systems. So, brief history. Like I said, I'm Seth Allen. I've been with Tycon since 2015 as the Sales and Marketing Manager. My main duty is to run a sales and support team along with marketing, but also to help educate our customers on how to properly use our products. So I'm going to jump in. Tycon's was started in 2008 by Scott Parsons. We started with three main brands of Tycon products. We have our Tycon Solar, which is what I'll be spending the majority of our time on today, Tycon Wireless, and Tycon Power. And I will be covering a bit of our Tycon Power products as well. So what I'm going to be going over are our Tycon calculators, our solar calculators. Two different sites that you can go to, the tyconsystems.com/calculators. This will, by the end of the webinar, you should be able to go and design your own RemotePro and UPS Pro systems. Or if you still need help, which we're always willing to do, we offer a free system design, and you can go to tyconsystems.com/request-system-design. And our design team will be able to help get all of the requirements for you and present a complete system design. To do this, we need to know the part numbers for all of the devices you're powering and the zip code or city, state, country that you are installing in. Reason for this is we're looking for the total power draw of all the devices. So when we look, we pull up the manufacturer's data sheets, we find the total power draw and look at the voltage requirements, because manufacturers have different voltage requirements for each of their devices. And then we look at the zip code or the city state, or if you're in another country. So we can look at the peak sunlight in that area. And with that, we're able to design a system that will continually power your devices completely off grid, or if you have partial grid power, or if you have grid power but need some battery backup. So when you go to the tyconsystems.com/calculator page, this is the first calculator you see. It's our RemotePro system. This is the RemotePro is the name for all of our off-grid solar systems. Here are the specs that we need. We look at the total load in watts. We look at the hours of operation per day. That could be changed whether you're using, powering a device for 30 minutes or 24 hours. The average hours of peak sunlight per day. And then if you want to add some extra battery backup. So we're going to do a couple of different designs for you. The first is going to be a security solution. This was what we received from one of our customers. We're looking for a solar solution to power a camera and access point in a public park. So the part number they gave us is the DWC, and you can see the rest. It's a simple dome camera. Looks like it's a bit of PTZ as well. And then they're going to use the UAP AC. It's just a outdoor access point. I apologize on the picture. That was the best I could find. And they are installing in Winnie, Texas. So what we do is we first Google the part number. So we find the data sheet for the DWC, and we see that it is 7.5 watts to be powered at 802.3 AF, which is the 48 volt standard. The UAPAC is 8.5 watts, also 802.3 AF. So both are 48 volt. Now to power both devices, we're going to need a switch. And so we're going to recommend our SW5G-24. This switch will convert 24 volt to the 802.3 AF. But since it is a device, it will have draw. So we need to add that 4 watts. So that gives us a total power draw of 20 watts. And then, so we can plug that into the calculator. So you see the load in watts is 20 watts. And this is going to be operated at 24 hours a day. So they want it full time. Now we look at the average hours of peak sunlight. So you can see to the right, you see the lookup tab. You'll click on that and that'll open a new window and you can put in the location. So we're going to put in Winnie, Texas. And here are the peak sunlight hours per day by month. Now we always look at the lowest month of the year. We know that if we're powered at, for example, in December, you have 3.82 hours of peak sunlight per day. And we know if it's powered in December at that average, we know it'll be powered year round. So we're going to plug that into our calculator. Now, when I do a system design, I like to keep the extra hours of battery backup needed at 0 to start. So I can kind of see what we're playing with. And then you can always go back and change that up to 24 hours or 48 hours if needed. But with this design, you will have complete autonomy, 24 hours a day of power. So when you hit calculate, these are your results. So 20 watts, total power draw, 3.82 hours of peak sunlight. You will need a minimum size solar panel of 144 watts and 80 amp hours of battery bank at 12 volt. So the systems recommended, you can see here. Now I'll do a little bit of a system breakdown of what our part numbers mean. The RP stands for RemotePro. The next is our enclosure type. So these would be our small aluminum enclosures. You have several options. We have the 12/24, 12/24M. Like I said, I'll explain that in just a second. With this, I'm going to go ahead and go with the RPS 12/24M. This will give me 24 volt output from our MPPT controller with a 100 amp hour battery bank and 170 watt solar panel array. This is what your system will look like. So it's 2 of our 85 watt panels that you will wire together in series. And all of our RemotePro systems include the solar panels, solar controller, the enclosure to house all the batteries and equipment, does include the batteries and all of the cables and mounting hardware needed to connect the batteries and panels through the solar controller. The only thing that you're providing in this application would be obviously the equipment, the pole that you're mounting to, and the Cat5 cable that's going to your equipment from the switch. This is a part breakdown, so you can kind of see we have our enclosure type is after the RP. So we have our die-cast aluminum enclosure, just a 10x8x3, so very small for smaller applications. PL stands for polycarbonate. It's a slightly larger, it's our poly enclosure. We have a small and a large pole-mounted aluminum enclosure, and then our large steel enclosure, and then a large ground mount aluminum enclosure. The next is going to be your battery voltage output. So the 12/24 means you can wire the batteries at 12 volt or 24. Obviously we have 48 volt DC output options as well. The 12/24 or 12/48 without the slash means it's going to be a 12 volt with a 24 volt or 48 volt PoE output. 24/24, 24/48 is going to be 24 volt DC along with 24 or 48 volt PoE output. We also have, if there's an M, that means that our MPPT solar controller is included. If there's no M, then it's a PWM. I will explain what that means in a little bit. Next is your battery capacity. So we have from a 9 amp hour up to 1400 amp hour battery bank. And then last is our solar panel array. And we have from a 15 watt solar panel up to 2100 watts of solar array. So here's another example, Wi-Fi hotspot. They're doing a wireless hotspot zone and needed solar to power this completely off grid. They need it running 24 hours a day. They're using the Cambium EPMP 1000. Which pulling up the data sheet was just 5 watts typical output at 24 volt PoE. And they're installing in Gambia, West Africa. Now the lookup tab that I showed you, that only shows for US. But if you look at the notes for international locations, use PV Watts tool. You can click on that and that will open up a new window. And this is a international database. You can type in the country, the city country that's located, and it will find the nearest. So this is you can see that it's Dakar, Senegal, but it's 170 miles from the Gambia. So we looked up Gambia, and we were able to, once you find your city in the country, you can hit that right orange that arrow on the right, and that will give you some information that you need to put in. So we look at the only thing you really need to worry about is the tilt. Then you can do that also on our page. We have a tilt calculator that will, you type in the latitude and it'll tell you the optimal winter angle. The goal is not to have to maintain these every season. So you set it the winter angle, and in this case would be about 15 degrees. They're just north of the equator, and the azimuth degree. So you're looking, anything north of the equator, you always want the panel south facing. Anything south of the equator, you want north facing. So for this, we're going to leave at 180 degrees. If you are south of the equator, then you would change to 0. So once we've done that, we can hit that right, the arrow, the orange arrow on the right, and that will give us the monthly average of peak sunlight. And here, again, typically December, January are the lowest months of the year. South of the equator, obviously, it's going to be in the June, July, August area. So we're going to look at 5.09 or 5 hours of peak sunlight for December. So fairly straightforward, fairly easy on this one. 5 watts as a total load, 24 hours of operation. Peak sunlight hours is 5. And again, we're going to leave that at 0. And it tells us that we need at least a 28 watt solar panel with 20 amp hour battery bank. And here are a couple options. So RemotePro PL for polycarbonate. And then we have a 12 volt option, or 1224 or 1248. Now, if you remember, the Cambium was 24 volt PoE. So with that RPPL 1224, that will give us a 24 volt PoE from the solar controller, along with a 36 amp hour battery bank and a 35 watt solar panel. So plenty sufficient to power that device 24 hours a day. And for those that, wondering what typical peak sunlight is, Arizona is going to be similar to this, where you're at 5.5 hours of peak sunlight in winter months. As you go further north, you're obviously going to have quite a bit less. Most places in the US will still have at least 2.5 hours, if not 3.5 hours of peak sunlight for December. But obviously our calculator will show you exactly what each location will have. This is what your system will look like. So you'll just mount again, it includes the solar panel, the enclosure, batteries, solar controller, all the cables and mounting hardware. So you just mount to your pole, set the appropriate angle, south facing, and you're ready to go. Our systems do not come pre-installed, obviously for shipping and safety issues. We do not pre-wire anything for you, but we do provide installation guides, which make it very simple to install yourself. Okay, one more system design that we'll do, another security solution, a little bit bigger this time. They're looking at security cameras for a parking lot. They're going to use the LTA Pro as their access point, 9 watts at 24 volt, and 4 rail link cameras. So each at 12 watts and 802.3 AF. So this is kind of a unique situation where you have one device at 24 volt PoE, which is a passive, not a PoE standard. And then you have 12 watts all at 48 volt at the 802.3 AF standard. And if you do have questions, I'm not going to go over much of the Tycon power today, but if you do have questions on what that means, passive, standard, feel free to reach out to us. We're happy to help. This is going to be installed in, I couldn't figure out if it was Chambersburg or Chambersburg, so we'll go with Chambersburg, Pennsylvania, and they average out 3.09 hours of peak sunlight per day in December. Again, just using our database to figure out the peak sunlight. We can plug that into our calculator. So that was a total of 57 watts. Notice I didn't add a switch. I will cover that. 24 hours of operation, 3 hours of peak sunlight. Calculate, and it tells us we need at least 500 watts of solar and 220 amp hour battery bank. Our suggested systems would be the RPSTL, so a large steel enclosure. Couple different options on the voltage output. 400 amp hour battery bank, and 720 watts of solar array. So that'll give us plenty of buffer, give us some extra autonomy to keep those devices running, especially in winter months when you may have a day of cloudy weather. The device I'm going to choose is the RPSTL 48. And the reason why, this is what you will look like. And with these systems that come with 720 or more of the solar panel array, we actually do include a 7-foot mast. These are giant sails, and so having them mounted to a pole is not ideal, a tall pole, I should say. So this would be bolted into a concrete pad for the safety and protection of the panels, keeping them low to the ground. This does include the 20 amp MPPT controller, 400 amp hour battery bank, as you see, 720 watt solar array, the large steel enclosure, which is mounted on the back, the mast, all the cables and mounting hardware. And the reason I didn't include a switch is this system comes with our TPDN SC4820. Now this is a 3-in-1 device. This is a 20 amp MPPT controller, 7-port switch, which each port can be configured at 24 volt or 48 volt PoE out. Also has a 24 volt or 48 volt DC auxiliary output, and it has our TPDN firmware built into it. I will cover that in just a little bit of the firmware. These are different types of systems that we offer. Now, each system, each app, we design each system based on your specific application. So, people will come to us and ask what system they need, or they'll try to, hey, what will this power? We try to do the design based on your specs. You tell us exactly what you're powering. We'll look at the total power draw, the peak sunlight, design the system, and make sure that you have enough power to keep everything up 24 hours a day. Or maybe you're doing an irrigation pump. As you can see, the top left is our 15 watt panel with a DC enclosure. It has a 9 amp hour battery bank. That'll give you 2.5 watts of continuous power with 6 hours of peak sunlight. Well, that's not a lot. This device is designed for small applications. Maybe you're powering an irrigation pump and only need to run it 30 minutes a day, because obviously you're going to have much higher than 2.5 watts draw. So each is designed with your specs in mind to not over design, and definitely not under design, but find the appropriate system with a buffer so that if you do have some cloudy weather, or maybe there's dust on the panels, or maybe the tilt is off, there is a bit of a buffer built into this. And so we have 2.5 watts draw all the way up to 300 watts continuous. And you can see the panel size and array based on how much draw is needed. Now, these specs are based on 6 hours of peak sunlight. Now, again, you're not going to have 6 hours of peak sunlight in most areas, but this is so that we can have that, have a fixed number to go with all of your variables. We also offer a mobile solar system. Now, this is going to be similar to the design we just had. You just put it on wheels. It comes with 720 watt solar panel, 720 amp hour battery bank included in that aluminum enclosure. This is completely wired in. So that is pre-wired for you. It shows up to your door and it's ready to install, or sorry, ready to deploy. It does come with an 18-foot pneumatic mast. There is a compressor in the enclosure as well to make it very simple. So you connect your equipment at the top. We do include a switch at the top of the mast with inside our enclosure. So you'll just run the cables, mount to that mast, and you're all set to go. It takes just a few minutes to install. So this is nice because you can park in your parking stall, or you don't have to angle the trailer itself, but you can, once you park it, you set the blocks, the legs, and balance it, and then you can turn the solar panels so that they're south facing, and that does do a 360-degree turn. You can add our wind turbine to the trailer to give yourself extra autonomy and supplement charging. It does have an AC plug, so you can park it on at a construction site. If you're running low on juice, you can always connect it to a generator, recharge the batteries. We do have several color options. These were our standards is black and orange. However, we've done many other colors, including yellow, green, blue, pink, even white. So you can provide our trailer team the color that you need, and we can look at making sure that that's available for you. Now, covering the PWM versus MPPT. The PWM, that stands for power width modulation. MPPT is maximum power point tracking. Now, these are our PWM controllers. This is our TPSC2420. This will give you 12 or 24 volt output on a 20 amp controller. The SCPoE, this will have a 12 or 24 volt DC option, as well as 24 or 48 volt PoE output. So you do have the dual output options but it's an 8 amp controller. The main difference is MPPT is better for low sunlight areas. It can also handle a higher voltage input. It's intelligent enough to be able to accept a higher current and be able to charge the batteries quicker. This is an example of one of our MPPTs, the SC. We have a 40 amp or 60 amp option at 24 volt, also obtaining 12 volt DC if needed. And we have our 4860. This is going to be a 48 volt 60 amp option. And then again, our other MPPT controller, as we talked before, is the TPDN SC4820 with the PoE switch built in. Couple different applications that we've seen. So this is just a very unique. I love this this design that we did in that in the middle of a lake, they had an osprey nest, and they wanted to monitor the hatching, the migration patterns, and they had a camera that they had installed just above the nest, but needed a way to get power to it. So we were able to do that design for them, and that was just kind of a fun, unique design. We have many different areas all over the world where our systems are installed, whether you're powering at a mountaintop or just a site where you need some extra battery backup, or maybe you're not able to tap into that grid power, but you needed to power some access points. So here you see just a completely off-grid, middle of nowhere, but you have some local towns nearby, and you have those Wi-Fi antennas that to send the signal out to your customers. So just a great design for that. Construction is extremely big. Security obviously is a growing industry. This bottom right it's just a city sign in Ohio. They needed they wanted to power some LED lights to light up their city sign at night. So it's just part-time power. They didn't want to trench through the parking lot, and so this allowed them to just run off grid, save the concrete, and not have to re-pour or anything, and be able to power those LED lights. Construction is big, especially in where they're starting to build new construction areas. So they're able to throw up some cameras for make sure it's watching their equipment for them. And this was a festival, and they needed some POS for people charging at the different tents, and needed a way to get Wi-Fi. So a lot of different applications that we see. Our design team gets unique applications every single day. More common applications is just doing a wireless bridge or access point. Security cameras, as I mentioned, remote lighting. We've done several designs in Africa where they don't have power at schools for children, and so they're able to power the cameras completely off grid using our systems. Irrigation pumps, remote sensors, and gates and turnstiles. So anything where you need power and don't have the availability, it's typically a great application. Now we're not doing residential or businesses. We're not powering complete buildings. That would be for somebody else, but we do specialize in anything that's off grid. Now, if you are in an area where maybe you do have some extra, maybe you have some extra cloudy days, or you're right on the cusp of needing to go up to the next system. For example, let's say you needed 150 watts of solar array, and so we have our 170 watt solar panels. You know, that gives you a 20 watt buffer. But in those winter months, you might have a day or two of cloudiness. So our Breeze Pro can be added to any of our 12 volt or 24 volt solar applications. It has a built-in solar controller, or sorry, built-in controller that you'll tie directly into the battery bank. And that will help charge the batteries when sun goes down, but it still has good wind, and it'll help supplement. Startup speed is 4.5 miles an hour. And when you are, the controller will recognize when your batteries are full, so it doesn't overcharge. It'll send the current out through the tail, so that you're protecting the batteries. And it's rated up to 400 watts of maximum power output. So just a great supplement, not for every application, but for those areas, especially Midwest, where you do have good winds, but extra cloudy days, especially in winter months. It has a braking system built in as well, so it prevents overspinning and protecting the blades. So I want to do a quick UPS calculator. This one's very simple and straightforward. We don't need to find the sunlight in that area. So we'll just take a similar application that we've seen, but all we need to know are the total load in watts and how many hours of backup power is needed. So here's an application we just saw for some security cameras. They have power at the site, but they wanted to make sure that they had some extra battery backup so that they could get out to the site if power goes down for an extended period of time. So they're using the Cambium access point that's 12 watts at 24 volt PoE, and then 3 of the Alhua cameras at 10 watts at 48 volt. Now we are going to add our switch on this. This is the 4 watt at 48 volt input, and I'll show you why we're going to use this versus switch. And so total power draw is 46 watts, and they wanted 24 hours of backup power. So we plug that into our calculator, hit calculate, and we see we need at least 184 amp hours of battery bank. This will give us that 24 hours of backup power. And you can see the different options. For this, I selected the UPS TL. No, I think, sorry, back up, UPL 12/24-200-600. I went with the smaller footprint over the UPS TL. The large steel enclosure will hold up to 400 amp hours of battery bank. We didn't need that, so I went with the UPL on this one. That's our large aluminum enclosure. We'll do the 24 volt at 200 and 600 watts capable. So all of our UPS systems include the enclosure, the battery bank, the battery charger with the AC power cord, the solar controller, which what this does is does all the brain work of the battery charger. So the battery charger will connect into your AC outlet, connect into your solar controller, then the controller will connect to your cables and have your load output. And then again, all the cables and mounting hardware are included. Now with this switch, this will give you a 24 volt PoE output and 3 at 802.3 AT. So that will be able to power all 4 devices from that switch. Here are the different UPS options. We have 30 watt capable, 60 watt, 120, 600 watts. That could be either the large aluminum or our large steel, or the ground mount aluminum at 900 watts. Obviously, all of our systems are designed based on the specs, so their sizes may vary depending on how much load and how many hours of backup power is needed. So again, that calculator very simple to use, but our design team is also available to help. Now for remote areas, Many people needed a way to be able to remotely monitor and control their equipment without having to drive out to their site. Or we have customers that have to either helicopter in or take snowmobiles in the wintertime. So not all sites are easily accessible. So we designed the TPDN Monitor Web 3. This allows you to remotely monitor and control your equipment. So you have 4 relays that you can set up, 2 normally open, 2 normally closed. This allows you to reboot your equipment remotely. You can log in through web or SNMP. We have a free app that you can use or access through your desktop. We have 4 voltmeters, 4 current sensors, and 2 temperature sensors. You can also set up compound logistics. So you can set up, if voltage drops, then do this, as well as set up email alerts so that you can be notified if you set up the ping to say, hey, ping every 30 seconds. If I don't get it after 5 tries, send me an alert. So you can do all kinds of logistics with that on the free firmware. There is no monthly subscription to this. Once you own the device, you own that, and you're able to log in. And then you also obviously have the data loggers and history graphs. So if you can see that your sunlight's going down or you're not getting enough sunlight to charge your batteries, you can see what's going on and look at your patterns. So just a very handy tool to have to access your equipment, not have to drive out to each site. It doesn't have to be used exclusively with our RemotePro or UPS-Pro system. It can be used in a home. Maybe we had one customer that had a cabin in the woods, right out in the mountains, and wanted to make sure that the temperature didn't drop below a certain temperature range, because then he knew his heater went out and his pipes would freeze. And so he set up email alerts for that. Several different PoE switch options we have. We have passive and compliant, which is a PoE standard of 802.3 AF, AT, or now BT. Passive just means what you send through is what you're going to get out. And then the standard is there's a handshake to protect equipment. We have unmanaged and managed switch options. And then we have from a 3-port switch, a 4-port switch, 5 and 8-port with fiber output options as well. So our design team will, when we're doing that system design for you, if you don't have a switch in mind, or we're able to help make some recommendations as well. So our switch here that's on the left is our SW5G-24. That's the one I'd mentioned before, that accepts 9 to 36 volt DC and will convert to 802.3 AT power on 4 ports with your data uplink as that 5th port. The Versa switch on the bottom is also an unmanaged switch. It does require 48 volt, but you'll get 1 port at 24 volt PoE, 3 at 802.3 AT, or 30 watts per port, and then a 60 watt high PoE port. So very versatile. You're able to use with many different applications. Now, we also have the managed. We have a 4 and 8 port option. We have where they do require 48 volt DC input to be able to access PoE out, but these will be on 802.3 AT output, as well as we just released 2 new switches, both 8 ports, which allow you, one will give you 24 volt PoE or 48 volt PoE at 802.3 AT. So you're able to configure based on what your needs are. And we also have an 8 port that has 24 and then 802.3 AT, and also 2 ports at 802.3 BT, which is the 90 watt standard. So many different switch options, whether you're using our RemotePro system or UPS-Pro system or not. Just a lot of great unique options that we've presented in the market for you. Now, as I mentioned, many manufacturers have different voltage requirements, and so we specialize in everything low voltage. So if you have a specific voltage input and you need a special output, chances are we design it for you. So we have several different voltage regulators as well as DC converters, where you'll take data and DC volt in, and then it will convert to be able to send power and data on one Cat5 cable. Different PoE converters as well. Let's say you have a 48 volt switch and you need one port at 24 volts. You can use that the PoE converter 4824, which converts 48 volt down to 24 at gigabit. Many different options. We would have a 3-hour webinar if I went over everything that we offer that's unique to the market. Most of our inspiration comes from its users. So if there is something specific, you can reach out to us and we can help you find the right product, or look at designing something if it makes sense for you. That is the end of the information portion of it. Let's see if there's any questions that have come in. I apologize, I forgot to mention that please ask questions at any time. So let's check out the questions that we have so far. Let's see here. So what are the positives and negatives to the polycarbonate AL or steel enclosures? So the polycarbonate, it's a simple, small enclosure. So you are limited on space. It'll hold up to 36 amp hours of battery bank. It's IP54 rated or NEMA 3. So it's not complete, it's not going to be waterproof, but it does do a great job of housing and keeping everything protected. It's sealed, except for the very bottom where we have some, we do have some rubber stoppers to be able to, prevent, if it's raining or anything like that, harsh conditions to enter in. Our AL and steel enclosures are all IP65 and NEMA 4 rated. So they will, so they are obviously protected more. They also include a fan, a thermostatically controlled fan, so that when temperature hits a certain high, it'll turn the fan on and help keep the equipment cool. Obviously, heat isn't a friend to your equipment, so that helps protect that. The polycarbonate enclosure, unfortunately, doesn't have a fan, but typically not needed when shaded because the plastic is a cooler plastic. Let's see. So let's see. Paul asks, do you have anything that provides cellular to the units to get data out to remote sites? We do not. At this time, we have several distributors that we could point you in and get you in touch with. We don't specialize in cellular. We do have some point-to-point bridge options, but cellular isn't that wasn't in our specialty, and we want to make sure that what we do well. So, like I said, I can get you in touch with some cellular companies, or if you have line of sight, in the 3 mile range, 3 to 6 miles, and we have some options for you there as well. Let's see here. We have, what type of batteries do we use in our systems? So we use lead acid AGM batteries. Currently, we are testing some lithium batteries. Oh, and then what are benefits of our batteries? So AGM versus lithium. So, the obvious answer for pros and cons of AGM versus lithium is that the AGM are going to be less expensive by quite a bit. They are much less expensive, and logistically to ship, they're much easier because it's non-hazardous material. Lithium logistically is more of an issue to ship. Companies airlines don't want to ship in the air, so. But that technology is improving, and the logistics of getting it where it needs to be are improving as well. So we are in the process of testing to look and make sure that we are, see that is a viable option. All of our MPPT controllers will work with any type of battery. So if you do have lithium batteries that you can source locally, at the moment, we can design a system that doesn't include the batteries, and you're able to excuse me, you're able to connect to the MPPT controllers. Benefits of lithium, they're much lighter weight, they're smaller footprint, so you can add more batteries, but like I said, they are much more expensive. AGM batteries are generally recommended to be discharged to 50% of their capacity. So that is, one of the cons of an AGM is that when you discharge more than 50%, it will limit the lifespan or lower the amount of charges. The lithium batteries are not affected by the depth of discharge, so it has a much longer cycle life. So discharging to 80 to 90% means fewer batteries and longer lifespan. So hopefully that answers that question of the AGM versus lithium. Again, our MPPT controllers will work with either. What colors do your enclosures come in? Our enclosures are a bit of a beige. I don't have the exact color for you, sorry, but they are a powder coated aluminum and steel with zinc oxide coating, and then it's powder coated. So it is a bit of a beige. We wanted light colors so that it doesn't absorb the heat. Our ground mount aluminum enclosure is checkered bright aluminum. So hopefully you're able to get the colors from that. Somebody asked, how do you regulate temperature? So again, our steel and aluminum enclosures include a fan, so that helps keep cool, and there's also vents to help suck in the air and push out through the vents. So that helps keep the temperature cool for when you are in a colder area. Typically the equipment that you have installed in the system is enough to keep your equipment so that it's not too cold, right? Because temperature will affect battery lifespan. So that is an issue, but the fan helps keep it cool. That's usually our biggest concern, is not having it overheat. We have had customers that are in the northern part of the US and Canada that have buried their batteries. It's obviously the warmer underground when the temperatures get to -40 degrees. So that is an option as well, or you can line it with some protective liner that helps keep it cool and warm. Any maintenance required on the enclosure? No, and that actually goes for all of our systems, because like our batteries are sealed, they're considered maintenance free. There's very little maintenance required on enclosures. Now, when you're in an environment of with high salt content, so maybe you're near oceans, you may want to, especially with those steel, things can get chipped, things can start to rust. So we do have a touch-up pen available that matches the color of our enclosures, so that you can touch those up and it helps protect it. You can spray with Rust-Oleum and then spray paint to help protect, because when you have exposure, that will tend to rust. Now, we've seen some of our enclosures in harsh environments in Puerto Rico that have been out for several years. There's obviously, you can see that it's been out there for a long time, but they're still holding up quite well to the harsh salt environment, even with very low maintenance. But that is one of the reasons that we really recently released our aluminum enclosures, because the aluminum does much better. They are lighter weight, but they are much better to play with in the salt areas. So how do we ship the systems? So we send, everything is stocked in our Utah warehouse. As a system is purchased, we ship. The best way to protect the equipment to arrive. Typically, when you're ordering one system, it would ship ground. If we're shipping 2, 3, or more, then freight is usually the best option. Everything is packaged individually. We will throw in some like the cables inside the enclosure to save an extra box, but batteries are padded and packaged. The solar panels are padded and packaged so that it's protecting all the equipment and arrives safely. Last thing we want are some nicks and dings in the enclosure, the panels, or batteries. Okay, it looks like that's all the questions that have come in. If you have any additional questions, please reach out. I do appreciate you guys joining today. Our email, we can be reached at sales@tyconsystems.com. That will go to anybody in our sales team, and we all work together to give you a timely response so we can make sure we answer all of your questions quickly. We are available as well through online chat. You can reach us at tyconsystems.com, or you can call us. And I apologize, I didn't put our phone number here. If you want to write it down, it's 801-432-0003. And again, we're accessible to help you out. The goal here is to educate as much as possible. So even if you feel comfortable now, hopefully you feel comfortable designing your systems, please feel free to reach out to our design team just to confirm. And you can say, hey, I did this. This is what I came up with. Can you just verify? And we're happy to help you in any way we can. So again, thank you so much for joining the Tycon Systems RemotePro System design calculator. Hopefully that was a good information for you, and we appreciate your time today. We will be posting this to our site and to YouTube. So if you missed something or weren't able to attend the whole thing, you can access it later. So thank you so much and have a wonderful day.